In this example, we need to find the derivative of this function given here as 25th power of x to the power 4 plus 3x square plus 2x plus 1, right? So this is the function we have given, and then our goal is to differentiate this function with respect to x. So here, if you look at the structure of this function, you can clearly see that it looks like it's kind of a function, right? A base function raised to the power n. So we have a function raised to the power n. So if we have that, then actually we have so this is kind of one of the particular case of the chain rule we can apply, which is said to be as generalized power rule, right? Which is, if you have a function raised to the power n, then the derivative of that can be figured out by bringing the power down as a coefficient, write down the base function as it is, subtract the power by 1, and don't forget to multiply by the derivative of the base function. So this is the generalized power rule, right, which is the particular case of the chain rule. So let's apply this rule to find the derivative of this function raised to the power something. So if you compare with this with the given the formula over the, if you compare this given function with the formula over here, the f over here, the base function is this x to the power 4 plus 3x square plus 2x plus 1, right? And then in the power we have here at as 25. So if that is the case, let's apply the generalized power rule. So how the generalized power rule works, we need to bring the power down as a coefficient, which is on this case 25. Write that down, and then we need to write down the function, the base function itself. So in this case we have that as x to the power 4 plus 3x square plus 2x plus 1, right? And we need to subtract the power by 1. So 25 minus 1 will be then 24. And now we need to multiply by f prime. So how do you find that? F means the base function, so that means we need to find the derivative of this function over here, x to the power 4 plus 3x square plus 2x plus 1. So let's find the derivative of that. So since there are a couple of terms, because of the sum rule we can actually find the derivative term by term. So let's find the derivative of x to the power 4, which is by the power rule just 4 times x to the power cube, right? And then plus, what is the derivative of 3x square? The derivative of the 3x square will be, 3 is a constant, multiply by x square. So 3 times derivative of x square, which is derivative of x square is 2x. So 3 times 2x will be then 6x, right, is the derivative of 3x square. So we have plus there, and now we just need to find the derivative of the 2x with respect to x, which is just 2 times derivative of x with respect to x, which is just 1. 1 times 2 then will be 2, right? And then plus derivative of 1 with respect to x. 1 is a constant, so derivative, and that is alone, so the derivative of that with respect to x will be 0. So this is the proper use of the generalized power rule here to find the derivative of the given function. The derivative is done over here, but if you want to simplify this or rewrite the given function in an alternative form, we can write down this as 25 is a constant, multiply by, we can write down 4x cube plus 6x plus 2, right? So this is our f prime, and there is a product, so we can reorder this if we want. So we can write down in this way, and then times x to the power 4 plus 3x square plus 2x plus 1 raised to the power 24, and this is the required derivative of the given function.